These are the 2.6 notes. We've got other types of equations. This is page 1. We definitely want a review of rational exponents because we're going to need to use those to solve. Okay? So first things first, it's typically, let's make sure this is not going to get in our way. It's typically this little negative that gets us hung up. So we're going to leave that for a minute. I do want to talk about what a to the m over n means. The exponent, the numerator, is always the power on our base. That denominator is always the index on our root. So a to the mn means the nth root of a to the m. That negative means take the reciprocal, moves from the numerator to the denominator or the denominator to the numerator. Okay. Does not change the sign of the expression at all. It literally just moves it into the denominator. Okay. Example 1, we want to write each expression with a positive exponent. So we are going to start by removing that negative piece, puts it into the denominator for us. Now I'm going to break this into pieces. I'm going to go 16 to the 1/4 to the third. 16 to the 1/4 means the fourth root of 16. That means what number can we multiply 4 times to get 16? That's 2. Still need to take that to the third power, and we get 1/8. B, we've got negative 27 to the negative 2/3. I am going to take care of that negative exponent first. And then I'm going to go ahead and take care of the cube root of negative 27. Oops, and that's going to get squared. Cube root of negative 27 is negative 3. We're going to square that. That even number in the numerator of our exponent means we end up with a positive answer. Okay. Here are some ways to solve. You can read through those. I'm definitely not going to read through them for you, but I will walk through example 2. So A, we've got x to the 5/4 equals 32. Keep in mind we want to solve for x to the first. So I'm going to raise both sides to the 4/5 power. 5/4 times 4/5 gives us 20 over 20, which is x to the first. And I'm going to go ahead and use that root first because I can find the 5th root of 32, which is 2. I get 2 to the 4th, which is 16. For B, I've got 2 different exponents on my x. I've got a 3/4 and a 1/2. I am going to start by moving everything to the same side. So I get x to the 3x to the 3/4 minus x to the 1/2 equals 0. I want to factor out an x to the 1/2, which leaves me 3x to the 1/4 minus 1. And then I'm going to move these up here. I get x to the 1/2 equals 0. Only thing that's going to make that true, I mean, I can square both sides, is x equals 0. I get 3x to the 1/4 minus 1 equals 0. I'm going to move that 1 over to the other side. I am going to divide by 3. And then we're going to go ahead and raise both sides to the 4th power. And I get x equals 1 over 81. Definitely writing too big on this one. So here are my two solutions, x equals 0 and x equals 1 over 81. For C, I definitely want to get my x variable by itself, so I am going to start by adding that 5 to the other side. And then I'm going to go ahead and divide both sides by 4, and I get x to the 2/3 equals 4. I can then raise both sides to the 3/2. X equals square root of 4 raised to the 3, 2 to the 3rd. I get x equals 8. D, I want to start by moving everything to the same side. Got x to the 1/2 minus 5x to the 1/4 plus 6 equals 0. 1/2 is 2 times 1/4, so I know this is a quadratic, and here's what I'm going to do. Just to make it a little easier, I'm going to let w equal 1/4. That means that my w squared, well, my w equal x to the 1/4, is x to the 1/4 squared, which is x to the 2/4, which is x to the 1/2, which means I've got w squared minus 5w plus 6, which is a whole lot easier to factor looking at this way. So I've got a w equals 3, w equals 2. Again, my w, though, is x to the 1/4. I'm going to raise both sides to the 4th power. And I'm going to squeeze in my solutions over here. 3 to the 4th is 81. 2 to the 4th is 16.